In today's lecture, we'll start with the third module of the course, which is the application security. And I have picked one topic called the email security for today's discussion. And the agenda for today's lecture is the following. So we'll understand what are the security requirements of an email system, in particular the email communication, and couple of methods, security methods, which provide security to the email communication. That's called MIME, and second one is DKIM. So that is the goal for today's lecture. So let's begin by asking this question. What are the security requirements of an email communication? So let's say I send an email. Now here it's me who is sending a mail to, let's say, the person X, and email goes from E to X. So let's call that email as E. So what are the security requirements in this communication setup? What exactly do we require? So the first one, in general, the email security requirements are no different from security requirements for other applications. Those are confidentiality, integrity, and authenticity. So if I send a message with, let's say, the email contains the content hi, I am saying hi to X. Somebody who is sitting in the middle should not be able to read what I am sending to X. That's the confidentiality. And when the message itself, E itself, arrives at this place, so I don't want that email content to be modified by the person sitting in the middle. I don't want hi to be manipulated and X receives hello. This is not desirable. And the third requirement is when X receives the email in his email box, he should be sure that only I have sent that message. I have sent that email. So that is called authenticity. In a way, X can actually verify that the email is sent from an authentic source whom X knows, so that he can actually read that. So these are all the requirements. So the same CIA principles, whatever we talked in the first lecture, those are all applicable to email communication as well. So we need some mechanisms which actually ensures this. So in some sense, we discuss how do we actually achieve confidentiality, integrity, and authenticity in the first lecture. This is typically done with using something called as the cryptography. So even while discussing the password security, also we briefly you discussed how exactly the hashing algorithms are used and things. But let's go review that basic cryptographic algorithms here once again, and which are used in email security systems. So the first one is, let's say I have a message M, and I want to transmit this message M to some recipient. So here in the previous example that I told, it was me who was sending the email and X was the recipient. So when this message M is sent, so I don't want, since the person sitting in the middle can actually read that, I don't send the message M as it is, but I use an encryption algorithm to translate this message M to some non-readable format, meaning in some other format which is actually sent to the recipient. So he might, when I transfer the message, it was me who was sending, X is receiving, the M can actually receive this message, and this is, let's say, this is M prime. So M prime is taken as input and a companion operation happens. So this is called decryption algorithm. So this is the reverse of what we did in the previous case. So this encryption algorithm can take a key, let's call that key as a K, and when we encrypt it, we use K. When we decrypt it, that time also we use K. So once I do this operation, what I get back is the original message M that was transmitted me. So this is what X is supposed to read. So he actually receives M prime, which is an encrypted version, but then he reverses the whatever the operation that I have done while sending it, and then he should be able to read the message. So this ensures that the message is actually, the email message is not being read by. So M prime, reading M prime doesn't make sense. So if my message is, let's say, hi, so when I encrypt it, M prime might look something like this, PQ78. So what is PQ78? The adversary doesn't know who is sitting in the middle. So that is what happens. So this kind of the encryption and decryption, since both of them uses the common key K, is called as symmetric in general, symmetric key encryption. So whenever you use the same key for both encrypting and decrypting, so that is called as the symmetric key encryption. So this is one way of achieving the confidentiality while transmitting the message. So this is not exactly used, we are just basically discussing the fundamentals. So that is one form of the encryption and decryption. The second form of the encryption is something called as the asymmetric key cryptography, or this is also called as the public key cryptography, or this is asymmetric key cryptography. So what happens here is, instead of one key, we have two keys. One is the one part is called public key, that is usually denoted with PU, and the second part is the private key, which is the denoted as PK. So as usual, the encryption decryption happens something like this. I still have a message M, and then I have the encryption algorithm, and I supply M to this encryption algorithm, and the message M gets translated to M prime as usual, and at the recipient end I do the decryption. I have the decryption algorithm, and that will give you the message M back. So in this case, this key, if I use the public key to encrypt the message M, and the decryption can be done with the other key, which is called PK. So on the other hand, if I encrypt the message M with a private key, and that can be decrypted using the companion key, which is the public key. So either one, whatever you use for encryption, the other part can be used for decryption. So that is how the encryption and decryption algorithms work. So how to derive this public key and private key pair is a different story. There are some methods with which you can actually derive such public and private key pairs. So assuming they are there, this is what the setup is. So you use one key to encrypt the message and the other one to decrypt the message. Unlike the previous case, where K is a common key bit for decryption and encryption both. So what if I am sending a message to person X and I need to share a common key. So only I and X need to know the key. But if I am exchanging the message with a large set of people, so for you to whoever I want to send a mail, so with each one of them I need to have a shared common key. That's the one of the issue with the symmetric key cryptographic system. But that is actually, if I want to send a common message to a set of people, what I can do is, I can, unless the message is actually not restricted to the people, I can encrypt with one key, and then the public key is anyway available with large set of people. Whoever wants to access it, they can decrypt the message and then find out it is actually sent from me. So that is actually an advantage with the public key crypto system or asymmetric key crypto system. So this public key cryptography is used in the methods that I am going to discuss now, both in MIME and on the DKIM security, email security systems. Another thing, so we also discussed this previously. We talked about the hashing while discussing the password security. So, what is exactly hashing? So, if we have a message M and that message M is passed to a hashing algorithm, and you get what you call as the digest or the hash. So keep, let's say my message is hi, and the hashing algorithm, there are something algorithm MD5 is one such algorithm. So once I give this message M hi, so the digest itself might look like something like this. So you have XYP9 T, something like this. So this is the digest. So this is fixed of the fixed size. So this digest algorithms are also used in the two methods that I am going to discuss in a while. So how the used a method called as signature is derived from the So the procedure itself look like something like this. I use the message yum, and that I give it to the hashing algorithm. You get the what you call the digest. This digest you take and you supply this to an encryption algorithm with some key, and what you get is the signature. So what, in addition to finding the digest of the message or hash of the message, what I'm doing is I'm encrypting that message with some encryption algorithm. Usually this key in this case is the private key that is used for the encryption, and the encryption algorithm, if it is a private key, then it's an asymmetric key cryptography method. So what it ensures this, since the private key is only known to me and the public key is known to everybody, once I send an email, if I attach my signature, this message to at the end of my email communication, so that the recipient can actually, using my public key, can decrypt this signature and get back the digest and go to the message M, which is in probably in the plain text format, recompute the hash value, and then compare whether the recompute hash value on the received M and what is the value that is derived out of the decryption of the signature are the ones which actually match or not. If these two matches, then we say that the signature verification is done. So how does it help? It actually ensures that, in a way, it helps the recipient that the message itself is indeed sent by the sender, because the private key is known only to the sender, and whatever I publish as a public key, if I am sending the message, anybody can actually decrypt the message, the signature, and then get back the digest and recompute the digest on the received message M, and compare the digest decrypted digest and what he has computed recently. If these two matches, then the signature verification is done. So this way I can actually verify that the message or the email itself has been sent by the sender who is claiming to be the sender. So this is actually used in providing the email security, in fact the security signature method. So with that cryptographic background, let's go and see how an email communication actually happen. So in typically how exactly a mail is sent from a sender to the recipient. So this is a setup. This is a diagram taken from this computer networks textbook from the Jim Cross. What you have here is a bunch of mail servers. So here is one, the second mail server and the third mail server, and a bunch of users. So user 1 is attached to this mail server, 2 and 3 to this mail server, Okay, maybe I should 1 prime, 2 prime, 3 prime are the mail servers, 1, 2, 3, 4, 5, 6 are the users. So these are the users usually. How do we access the email or send the email? We use either the web mail, log into the web interface, open a browser and then log in, or we can use some kind of the email clients, maybe the Thunderbird or the Outlook if we have configured. Those are email applications. Those are technically called as the user agents. So user agents are the ones which actually enable either help you receive the email or send the email to someone else. So when a user agent, if let's say user 1 wants to send an email to user 4, here is user 1, user 4, what exactly happens is the email client, here the user agent of the first user 1 delivers the message to the email server to which he or she is connected to. Here in this case, the 1 prime is the mail server. And it is now the job of the mail server 1 prime to find out where exactly the domain corresponding to the recipient is located. What is the server? In other words, who is the recipient mail server, which in this case is the 3 prime is the mail server, which is responsible for holding or receiving the message from the user 1, not in this case, because user 4 is actually a member of the mail server 3 prime. So now 1 prime establishes a connection with the 3 prime using a protocol called as the SMTP. This is called simple mail transfer protocol. So using that protocol, the mail server 1 prime delivers the message to 3 prime, and the message itself might get stored in the mail server 3 prime, and whenever the user 4 actually logs in, and then he can actually download that message and see in his inbox. So that inbox is again the user agent. So since email is in asynchronous communication, meaning that the sender and the recipient need not be online at the same time, the message might in the transient period can be stored in the mail server. So meaning if the 3 prime itself is not available to take the message at this point of time, the message itself might be get stored in the 1 prime, and whenever 3 prime is able to receive the message, 1 prime delivers the message. It might take not in one attempt, multiple attempts can be done, and then the mail can be delivered. So in between the mail server, the communications usually happen using the protocol called as the SMTP. And there are other protocols defined to just to download the message from the mail server. So for example, whenever user 4 wants to see that message, the between the mail server 3 prime and the user 4, the communication happens through other protocols, POP3 and IMAP and other protocols are there. So using them, the user 4 can actually download that message and see that. So this is how typically the email communication happen. So in a nutshell, the sender is connected to one mail server, the recipient is connected to another mail server, and the email exchange happen between these two. So when I say another mail server, it does not necessarily mean that 3 prime and 1 prime are the two different servers. It can be so maybe user 1 and the recipient also may be connected to the same mail server. In that case also, the email is stored in the mail server 1 prime itself. So now the next question is, how does the email look like? So the email content, typically when you open any email received which is there in your inbox, this is the content that you typically see. There is a timestamp when that mail was sent. So here in this case, December 21st, 2021. So at this time, 2 o'clock 15 minutes 49 p.m. Indian Standard Time, and who is the sender? Pram. And who is the receiver? In this case, sender is the xyz@gmail.com, and the recipient is pqr@outlook.com, and there is a subject line. This is the syntax defined in the RFC 5322, and this is the actual content, email content. hello, this section begins the Excel message body. So body is the one which is actually the carrying the content. What exactly I want to send to you or the person X, that is written inside the this body. So this portion from here to here is called as the email header. So these are the common things that we see when we open the email, but these are not the only things that are there in the email header. There are a bunch of other stuff that gets added as a part of the header, so which is actually typically hidden from the recipient. So, but you can actually open that and see. So there are other things. So one of the things is maybe there is a field called as the message ID. So let's call it MID. This is text. So that's actually going to part of that message ID identifies which it's a mail that is being sent. So that is how typically the email look like. And we want to protect two things. One is this message itself should not be modified. I am saying hello, this section begins the Excel message body. So somebody should not read this content. Somebody should not able to modify this content. And the recipient should be able to make sure that if whoever is the sender, if the mail is claiming to be arriving from xyz@gmail.com, indeed the owner of the xyz@gmail.com has sent this message. That is the requirement. So let's see how this is actually done. So as I said before, we actually discussed that. I said that the email itself is exchanged between the mail servers and between the user and the mail server. When it is sending, SMTP protocol is used. So SMTP can carry only the text messages, and that too even only the ASCII characters. So the only English characters were allowed as part of the email body, nothing else. But now we attach different kinds of the attachment to file types, the image, videos, even sometimes the emails are written in the non-English language, sometimes even different PDF files and others are attached, even the HTML is also sometimes as part of the goes. So these different data types were not supported by the SMTP protocol. So SMTP is limited to only the ASCII character, nothing more than that. Simple English text. You can write the email in this format, nothing more than that. So how do we actually enhance the capabilities of the SMTP? That was the question people started asking. And supporting these many different file types is one question. And the other thing is SMTP actually limited the total amount of the data that you can transmit as part of an email communication. So maybe let's say you cannot write beyond 1000 bytes. This is not the exact number, this is hypothetical. I'm just saying for the sake of example. So you cannot send a mail beyond 1000 bytes. That's the limitation. So we don't want all of this, but now we want all of different kinds of data to be transmitted, and there is no limit how big the email communication can be, and even transmitting the executable files were not allowed. So can we transmit the executable file? These are the kind of questions people started asking. As an answer to the standard came up something called as the multipurpose internet mail extensions. That stands for in shortcut MIME. So MIME stands for multipurpose internet mail extension. So what it did is retaining the structure of the SMTP. SMTP was allowing only the ASCII characters. It defined new header fields to be added to the SMTP structure. So remember, this is the header structure. So here in somewhere in that type, one of the field is with the type of the data or data type. So I can say this is text or ASCII was there. And now what MIME is saying is it is adding few more such fields into the email header. And with that, I can define new data. I can say this is the JPEG image, this is the MPEG video, this is the MP3 audio, and so forth. So all of them can be part of the email communication. And to do that, it defines different content types. Content types can be again image, video, and different types. And then it also defines something called as the encoding techniques. So if we have a message or some file type which is not natively understood by the SMTP, so you can convert that data type, original data type, into a format through which you can actually send it to the over the email communication. That is what the encoding means. So how do I transform the input of one type into an output of the another type? So such encoding techniques also MIME defined. So all of this helped us to transmit the different kind of the file types over the email. That is what the MIME is. So this MIME, again, although it is capable of transmitting the files at the different types, but it's actually not secure. So that is where the SMIME actually took the birth. So SMIME stands for secure MIME. So I am retaining the capabilities of what MIME is giving me. So rich transmission over the email communication, but I want to have the security inbuilt into that. So the design goals of the SMIME are the following. So as I said, I should be able to verify the sender, the original, who is the sender of this email, who claims to be the sender of this email. Can I actually verify his or her identity? And at the same time, I don't want the message to be email should be manipulated in the middle, and someone should not be able to fabricate a message and send. That is the man in the middle attack. So let's say I am the sender here and X was the recipient, and email is sent over this communication channel. Someone sitting here should not be able to fabricate a message and send it to X claiming to be originated from me. That should not happen. So that's the man in the middle attack. So that fabrication is also discouraged. How do I actually ensure that all this provided by the by retaining those rich communication abilities? So in order to achieve this SMIME defines something called as cryptographic message syntax. So I want to ensure the confidentiality or the integrity of the message, or I want to identify the sender or authenticate the sender who is actually sending that message. So in order to do that, it actually defined this syntax. So it defined 4 different data types. One is called as the digested data content type. Only this, there are different capabilities. So let's go over one by one. The second one is something called as the signed data content type, and the third one is enveloped data content type, and the fourth one is something called authenticated data type. Let's see what exactly happens inside this 4 different data types. How actually email is manipulated, or what changes being done to the email, and how the data actually look like. So let's assume I have the email content. So that could be an image, text, audio, any other different file type that you can think of that can go as a part of the email. And what I do is, in the digested content, this I pass it into the algorithm. So let's say, for the sake of this is my message, hi is the content of the email. I pass it to the hashing algorithm. So this can be again your MD5 or SSC 256, whatever it is, and you get a digest. So that digest is PQRT9, something like this. And what I do is, I take this original email as it is, and to that, at the end of this, I attach this component. What is this? PQRT9 also goes. So this itself as a bunch is transmitted to the recipient. So when the recipient receives this message, so he can see I is the message that is there as part of the email communication, and this is the digest that is. And so what he takes is, assuming the recipient knows which algorithm is used for hashing. So this content high is actually passed to the same algorithm, and then you calculate the digest again, and if this digest matches with that of the PQRT9, then it gives an assurance to the recipient that the content, what is the content? This content is not modified in the transit. So when I transmit this over the network, the email itself is not manipulated in the transit. So it gives you one of the property that you required over the email communication. What was that? Somebody in the middle is not manipulating the email content. So as the content itself is transmitted in the plain text format, there is no encryption that is happening over the content right now. Only the content is sent as it is, but as a digest is attached. So if you want only this capability from the email communication, this is the message data type that you should be using. All that I do is take the email content, pass it to the hashing algorithm, whatever digest you get, attach that digest to the at the end of the email, transmit it over the network, the recipient receives it, and then he recalculates the hash value over the message body and then compares those hash values. That's the first data content type the MIME uses. Remember, there is no encryption here. The second data type that it defines is something called a signed data content type. So this signed data content type, there is not only you also calculate the hash, but that hash is actually signed. So as usual, again I have the email content. So again, let's take this high is there, and then you have hashing algorithm. That's, let's take MD5. You get the hash PQRT9, and then you take an encryption or signature generation algorithm is an encryption algorithm. So to that you supply a key. This is usually the private key PK that is used as a means to sign, and then you get the signature. So PQRT9, when you encrypt using the private key, let's say it is 1 2 3 4 5 now for the sake of concern, and then you get a text something like this, get maybe X9T419, something like this. So this gets appended to the mail. So your mail is still high, and at the end of this content goes. What is that? X9T419. So this is actually transmitted to the recipient over the network. So when the receiver receives this email content, this bunch together, content, email body and the signature itself, what he needs to do, first thing is to take out this portion and use the decryption algorithm. Using the which key? We use the private key to encrypt the hash digest value. Now you need to use the public key to decrypt this. You get back the digest, and you take this digest, and assuming you know the algorithm, take this value, pass it on to MD5, and you get another digest, and you compare this digest with this digest that is there. If these two matches, then you say that the email content itself is not modified, and since the digest itself is encrypted using the private key, and I am able to decrypt that using the public key of the sender, and then it gives you the authenticities that the content itself is not modified in the transit. And in addition to that, I am also able to verify who the sender is. Now in this case, since the private key is used for encryption, the other key is using the other key, you can actually establish the authenticity of the itself. So it tends to give the assurance that the digest itself is calculated at the source, and that too by the sender himself or herself. This is the second Right. Again, in this case also, the message itself, whatever hi I was sending as part of the email, that is not encrypted. So anybody who is untransit, he can read the content, email content as it is. So if you look at the signed data or the email MIME communication, the origin might look something like this. The content type itself is identified by the application, this PKCS. PKCS stands for Public Key Crypto System, and the SMIME type, SMIME stands for Secure MIME type, is the signed data. Here is the signed data. So I am not only calculating the hash, but also I am signing that using the private key in order to establish the authenticity, or the who exactly is sending the email itself.